Hello, good afternoon, students. In our today's lesson, we are going to study about weathering. Weathering is a very important term in physical geography, and it is one of the denotational processes which wears away the landscape. Weathering, the term weathering comes from the word weather, and weather is the behavioral patterns of the atmosphere or the state of the atmosphere, which is made up of elements of rainfall, elements of temperatures, it is made up of elements of frost, it is made up of elements of air. So, in this case, we can therefore define weathering as the gradual disintegration or breakdown of parent rocks into increasingly small particles in situ by the action of weather elements. The word is in situ is very important in this definition because in situ means that there is no movement in weathering processes. The weathered rock particles will simply drop off and they settle at the foot of the major parent rocks. They don't move, and that's why the word in situ is very important in the definition of weathering. Weathering is brought about by the actions of weather elements such as temperature changes, frost action, and the actions of rain. So we are going to look at details of all this when we look at the types of weathering. So let's therefore go straight to the types of weathering. There are three major terms of weathering. We have physical weathering, or sometimes we call it mechanical weathering. We have chemical weathering, sometimes chemical weathering rather, and then we have biological weathering. All these various weathering processes occur in different ways, but they are interdependent, meaning one weathering process can aid the occurrence of another type of weathering. So in this case, we have to look at in detail the types of weathering. First of all, we shall begin by looking at the physical weathering. Physical weathering is defined as the processes of breakdown or gradual disintegration of parent rocks into smaller and smaller particles by physical means like temperature changes, like pressure release, without chemical reactions. And the resultant weathered rock fragments will have the same chemical composition as the parent rock. For example, if the rock which is undergoing chemical weathering is made up of calcium carbonate, you will find that the broken rock fragments from this massive limestone will still have the same chemical composition, and that is the calcium carbonate. Rocks which are made up of iron, if they break down into smaller particles by physical weathering action, you will find still these rock particles will maintain the iron mineral which has built up the major mass of the rock. So that is what is meant by physical weathering. This physical weathering occurs in various forms, and it's very important to also know the various forms in which physical weathering processes occur. One of the important types of physical weathering is what we call exfoliation weathering. The term exfoliation refers to the peeling of the outermost layer of rocks into thin layers. The rocks begin to peel off like the way onions the layers of onions get off from the main mass of the onion in thin layers. So when rock surfaces disintegrate in thin layers in this way, we call it exfoliation weathering. And exfoliation weathering is brought about by temperature changes, and is very dominant in semi-desert areas and desert areas of East Africa, where there is rift temperature changes during day and night. How does exfoliation weathering occur? During daytime in semi-desert areas, temperatures are extremely hot, and this brings about intensive rather, heating of the rock surfaces, and therefore rapid expansion of the rock surfaces. Then at night the reverse happens, that the temperatures are very cold at night, very cold. And these cold temperatures bring about rapid cooling of the rock surfaces, and therefore rapid contraction of the rock surfaces. This antagonistic expansion and contraction of the rock surfaces during day and night hours respectively bring about the crumbling of the rock surfaces in thin layers. The rock begins to weaken up in thin layers at the surface, and eventually it will begin to peel off. The exfoliation weathering is brought about sometimes by it is accelerated by rainfall. When there is a sudden rainfall after a very hot day, the rock surface will suddenly cool and contract, and this will lead to exfoliation weathering of the parent rocks. I repeat, it is very common in semi-desert and desert areas of East Africa, such as the northern part of Kenya and the Karamoja region of northeastern Uganda. When exfoliation weathering occurs, it brings about smooth surfaces of the rocks, or domed curvature of the rock surfaces. The rock surfaces are curved up by the processes of exfoliation in its smooth shape, domed shape, and therefore this kind of structure is termed as exfoliation dome. Exfoliation domes are very popular in the desert and semi-desert areas of East Africa. The second type of physical weathering is what we call temperature changes. This time around, unlike in exfoliation weathering, these temperature changes occurs and affects rock grains. It affects particular rock grains. When there is hot temperatures, the various rock sizes expand at different rates. The rock minerals expand at different rates. And when temperatures become very cold, the rock minerals will contract, will cool rapidly and contract within the rock masses. So this expansion and contraction of particular or individual rock minerals will bring about a weakening. It will create strains and weakness in the rock mass, and eventually the rock will begin to shatter up, or the rock will begin to break up in smaller and smaller particles. This form of weathering is not the same as exfoliation weathering, because it affects the rock grains, and it affects the rock minerals, and it is these rock grains or rock minerals which are therefore in charge of, which brings about temperature changes in this form of weathering. Thirdly, we have frost shattering or frost weathering process. This form of weathering occurs commonly in colder regions of East Africa, and more so the glaciated mountain peaks, such as the peak of Mount Elgon, Mount Kilimanjaro, the peak of Mount Ruwenzori, and the peaks of Mount Kenya, where temperatures are extremely cold because of the high um, altitudes. And these cold temperatures brings about freezing of water. Now, how does this frost shattering operate? It operates in such a way that when water accumulates in rock cracks, the water will freeze, the water will cool down and freezes within the rock cracks. Now, when it freezes, freezing of water brings about expansion of this water. So the water will expand, the frozen water will expand within the rock cracks. This will therefore bring about enlargement of the cracks. Then, as a result of slight rise in temperature, the frozen water will melt up. And when it melts up, it means it will reduce in volume. And given the fact that the cracks had already been enlarged, it means this enlarged crack can take in more additional water. And again, another process of freezing will take place. Freezing and expansion of the frozen water in the cracks occur. So this process will gradually bring about the shattering or breaking up of massive rocks in a glaciated region into smaller and smaller particles, a process known as a frosty shattering. Then another important form of physical weathering is what we call the block disintegration. Block disintegration. This is a form of physical weathering in which the well-jointed parent rocks break down into large rectangular shaped blocks caused by temperature changes, alternate cooling and heating and cooling of the rocks along these joints. When there is a hot temperatures, the rocks will be heated up and expand along the joints. And when the temperatures drop low, the rock will cool rapidly and contract also along these joints. So with the resultant effect that the rock becomes weakened up along the joints. And in doing so, the rock will begin to crumple down along these joints into large rectangular shaped blocks. So because the rocks break down into large rectangular shaped sizes, they have been termed as it is termed as a block weathering or block disintegration. The process of block disintegration can also be aided by chemical weathering. In other words, the rock joints becomes enlarged or increased when chemical weathering attacks the rocks along these joints, and the joints becomes larger and larger and clearly seen. Okay, so that is what we call block disintegration. So you can see therefore block disintegration should also be a popular form of physical weathering in semi-desert areas. Another form of physical weathering is what we call granular disintegration. Granular disintegration coming from the word grain. So this is a form of weathering in which the parent rocks break down into their separate grains. It is the grains of the rocks that pull off from the rock masses. Therefore, granular disintegration is very common in rocks which are made up of grains or crystals. And the major type of rock which is made up of grains is what we call the igneous rocks. I refer you to go and revise about the process of the formation of the igneous rocks. Most especially the plutonic igneous rocks, which are made up of different types of large grains. Differences in temperatures brings about the expansion and the contraction of these grains In other words, when there is a high temperatures, the rock grains absorb this heat and expands. And when there is a cold temperatures, the rock grains loses the temperature, heat, and contracts. So this antagonistic expansion and contraction of the rock grains due to temperature changes will bring about the weakening of the rock grains, and eventually the rock grains will begin to pull off from the rock masses separately. This form of weathering produces a very rough rock surfaces because of the pulling off of the rock grains. So it does not produce a true exfoliation dome, but rather you see rock surfaces which are very rough with a lot of spots and holes from where the rock grains have pulled off from the rock masses. Another form of physical weathering is alternate wetting and drying. Sometimes we call it aridity shrinkage. This is a form of weathering in which rocks which can absorb water are affected. When rock surfaces absorb large amount of water or large volume of water, the rock surfaces expand or swell outwards. And during the dry season, the rock surfaces lose this water, or when there is a dry condition, the rock surfaces lose this water through evaporation, and therefore the surfaces contract or shrink. So this gradual increase in swelling and shrinkage of the rocks, or swelling and reduction of the rock surfaces, will gradually weaken up the rock, and eventually the rock surfaces begin to peel off in thin layers. And it breaks or it fractures up in plate forms, and eventually it begins to pull off over the main mass of the rock. So this type of weathering is very common in the coastal areas where the sea level changes. When the sea level rises, the rocks adjacent to the coastline will absorb this water and expand. And when the sea level falls, the rocks will become above sea level, and they dry up and contract, and eventually the rocks succumb to aridity shrinkage. Another form of physical weathering is pressure release or unloading. Then lastly we have enlargement of salty crystals. But I will explain these last two physical weathering processes in our next lesson or in the succeeding lesson. I thank you very much for opening and listening to this lesson. I thank you very much. Please continue to read and read hard. Thank you very much.